Today we shall discuss about regression analysis. So far we have studied and learned the correlation analysis, which measures the direction and strength of the relationship between two or more variables. But here we can estimate or predict the value of one variable from the given value of other variable. For example, you take any two kinds of the variables, like price and supply. When these two variables are correlated, then we can find out the expected amount of supply for a given price, or the required price level for attaining the given amount of supply. So regression helps us to estimate one variable or the dependent variable from the other variable or the independent variable, or in other words, we can estimate the value of one variable provided the value of other variable is given. Therefore the method which helps us to estimate the unknown value of one variable from the known value of related variable is called regression. And here regression means returning or the stepping back to the average value. And in statistics, the term regression means simply an average relationship, and with the help of one independent variable we can estimate or establish the most likely value of another the dependent variable. And regression means the average relationship between two or more variables in terms of the original units of the data. And the dictionary, or the meaning of the word regression is return or going back, or stepping back to the average value. And in 1877, Francis Galto first introduced the word regression while studying the relationship between heights of fathers and sons. And he studied about the heights of 100 fathers and sons, and gave his opinion that tall fathers were having tall sons, and short fathers were having short sons. So therefore the regression, it is a statistical the method which is used to study and calculate or find out the value of one variable, the dependent variable, with the help of another variable called as uh, independent variable. So therefore it is a statistical the method or tool in which we are using for calculating or finding the unknown variable from the known variable. And here according to Blair, so regression is the measure of the average relationship between two or more variable in terms of the original units of the data. So it means that regression, it is the measure of the average relationship, measuring the relationship between two or more variables in terms of the original units of the data is called as the regression according to Blair. And another author, he defined regarding regression, namely Taro Yamne. So he defined regression as one of the most frequently used the techniques in economics and business research to find a relation between two or more variable that are related casually is regression analysis. So according to him, regression refers to, it means it is one of the most frequently used the technique, the statistical the technique which is applied or used in economics and business research to find a relation between two or more variables that are related casually in is called as regression. And so regression is um, regression analysis, analyzing the relationship of two or more variables by using statistical the method, and tool like regression is called as a regression analysis. And regression analysis is used in statistics in all those fields where two or more variable relative variables are having the tendency to go back to the average. So therefore it is widely used in social sciences like economics, natural and physical sciences, and it is used to estimate relation between two economic variables like income and expenditure. So therefore a regression analysis, it is a statistical the method which is used to study and analyze the relationship of two or more variables, and finding the value of unknown variable with the help of and support and help of the another known variable is called as regression analysis. And regression analysis predicts the value of dependent variable, predicts or estimates the value of dependent variable from the value of independent the variable is also is called as the regression analysis. So therefore regression analysis is very much useful to the economics and businessmen to estimate or predict the value of one variable with the value of another variable. Now, regression equation. So, regression equations are the algebraic expressions of the regression lines, are called as the regression equations. And there are two types of regression equations. One is the regression equation x on y, and the regression equation y on x. So, regression equation x on y is given by x minus x bar is equal to bxy into y minus y bar. So the regression equation x on y is explained as x minus x bar is equal to bxy into y minus y bar. When regression equation y on x is explained as y minus y bar is equal to byx into x minus x bar, and the bxy can be calculated under direct method as r into r means already you know the correlation coefficient r into standard deviation for x divided by standard deviation y. And when regression under regression equation y on x, so for that byx under direct method can be represented as r into sigma y by sigma x. And deviations, when deviations are taken from actual mean, then bxy can be calculated as sigma xy by sigma y square. And when regression equation y on x, deviations are taken from actual mean, then In case of y on x, byx can be calculated as sigma xy by sigma x square. Now deviations taken from the assumed mean. So when deviations are taken from the assumed mean, so then bxy can be known as can be calculated as n into sigma dx dy minus sigma dx into sigma dy by n into sigma dy square minus sigma dy whole square. And in case of regression equation, y on x uh, and when deviations are taken from assumed mean, then byx can be calculated as n into sigma dx dy minus sigma dx into sigma dy over n into sigma dx square minus sigma dx y square. So therefore the regression equations x on y and y on x can be calculated under these three methods: under direct method, and when deviations are taken from actual mean, and deviations are taken from assumed mean. So these are the formulae where we used to calculate or to find out regression equations x on y and y on x. Now solving some problems on regression equations. So here in first problem, correlation coefficient between x and y variables is 0.6. Standard deviation for x, sigma x is equal to 1.5, and standard deviation for y, sigma y is equal to 2, x bar is equal to 10, y bar equals 20. Find the two regression equation. So here we have to find two regression equations: regression equation x on y and regression equation y on x. And in regression equation x on y, regression equation x on y is explained as x minus x bar equals bxy into y minus y bar. You should keep in mind that when using regression equation x on y, so the equation must be x minus x bar. ಇದೇ ಥರನೇ ಬರಬೇಕು. x on y ಇದ್ದಾಗ x minus x bar equals bxy into y minus y bar. So now substituting values into the formula, x minus x bar 10 equals r into bxy. So under direct method, bxy can be calculated as r into sigma x by sigma y by y minus y bar, means 20, y bar 20. Now x minus 10 x minus 10 is equal to r value 0.6, and then correlation coefficient 0 point r is equal to 0.6 into standard deviation for x 2, 1.5 divided by sigma y, standard deviation for y 2 into y minus y bar 20. Now x minus 10 is equal to 0.6 into 1.5 by 2 equals 0.75 into y minus y bar 20. Now x minus 10 is equal to 0.6 into 0.75, 0.45 into y minus 0.6 into 20, 0.06 into 2, 6 2s are 12, 6 2s are 12, 0.00, and then x equals 0.45 y uh, plus 10, because when by transposing, minus 10 will become plus 10 when LHS into RHS, and minus 6 2s are 12, 12 9 this is not 9, it must be 12. 6 2s are 12, 12. Therefore x is equal to 0.45y plus 10 minus 12 equals, minus 12 is equal to minus 2. This is what the regression equation x on y. Now regression equation y on x is explained as y minus y bar equals byx into x minus x bar. So y minus y bar 20 equals byx. So under regression equation y on x, byx can be calculated as the formula r into sigma y by sigma x, standard deviation for y by standard deviation for x, into x minus x bar 10. Y minus 20 is equal to r value 0.6 into sigma y 2 by sigma x 1.5 into x minus 10. Y minus 20 equals 0.6 into 2, 2 by 1.5, that gives us 1.33 into x minus 10. Y minus 20 equals 0.6 into 1.33, 0.799x minus 6, 0.6 into 10 means 0.6, means 6. It should be 6, not 7.99. Therefore y equals 6.00 plus 20 minus 20 becomes plus 20 when by transposing, and y is equal to 0.799x plus 20 minus 6. Therefore y is equal to 0.799x plus 14, 14. It should be 14. So this is what regression equation y on x. Now take another problem to calculate regression equations. So if x bar is equal to 35, y bar equals 50, standard deviation for x is equal to 5, standard deviation for y is equal to 8, and correlation coefficient r equals 0.8. Then we have to find the regression equation y on x, and we have to estimate y if x is equal to 40. So here regression equations y on x, that is to be given as y minus y bar equals byx into x minus x bar. Y minus y bar equals byx can be written as r into sigma y by sigma x into x minus x bar. Y minus y bar 50 equals r value 0.8 into standard deviation for y 8 divided by standard deviation for x 5 into x minus x bar 35. Therefore y minus 50 equals 0.8 into 8 by 5 means 1.26x minus uh, minus 40, simplifying that value 44 0.8 into 1.6 into x 1.26x and m- and multi and into 35 means 44.8, then y equals 1.26x uh, plus 50, because uh, yeah, when LHS into RHS by transposing, minus 50 becomes plus 50 minus 44.8. Therefore y equals 1.28x plus 5.2. Now the value of y when x is equal to 40, so y equals here we have to estimate or predict the value of y when the value of x equals 40. Y is equal to, here we got regression equation y on x, y is equal to 1.28x plus 5.2, the regression equation. So with the help of that regression equation and substituting the given value 40, so we can estimate or predict the value of y. So y is equal to 1.28x plus 5.2 equals 1.28 into 40 plus 5.2. So therefore 1.28 into 40, 51.2 plus 5.2, therefore 56.4. This is what the value of y with the value of with the help of with the given value of x, given value of x. Now take the third problem. Find the two regression equation from the following: n equals 20 and number of observations or items sigma y is equal to 40, sigma x is equal to 80, sigma xy is equal to 48, sigma y square is equal to 320, sigma x square is equal to 1680. Now x bar, standard x bar arithmetic mean for x can be known as sigma x by no n is equal to sigma x 80 by n 20, 0 0 cancelled, 2 1s are 2 4s are 8. Similarly y bar equals sigma y by n, sigma y 40 by 20, 0 0 cancel, 2 1s are 2 2s are 4. Therefore x bar is equal to 4, y bar equals 2. Now regression equation x on y. So regression equation x on y is given as is explained as x minus x bar is equal to bxy into y minus y bar, and regression equation y on x is explained as y minus y bar is equal to byx into x minus x bar. So here x minus x bar 4 equals bxy means sigma xy 48 divided by sigma y square 320 into y minus y bar 2. So therefore x minus 4, 48 by 320 equals 0.15 y plus into minus minus 0.15 into 2, 0.3. So is equal to 0.15 y minus 0.3, and minus 4 becomes plus 4. So x is equal to 0.15 y minus 0.3 plus 4 plus 3.7. Now a regression equation y on x is explained as y minus y bar equals byx into x minus x bar. Y minus y bar equals b sigma xy by sigma x square when actual mean is used into x minus x bar. Y minus y bar 2 equals sigma xy 48 divided by sigma x square 1680 into x minus x bar 4. Y minus 2 equals 0.48 by 1680 0.286 into x minus 4. So therefore y minus 2 equals 0.286 into x 0.286x plus into minus 0.286 into 4 0.114. Therefore y equals 0.286x minus 0.114 minus 2 becomes plus 2. So therefore this is what calculating two regression equations x on y and y on x and finding the value of the value of the dependent variable with the help of independent variable. So this is the way in which we can understand clearly the finding of the values of x and y when x is finding y when x is given and finding the value of x when y is given. This is called regression and regression analysis.